Hello everyone, I welcome you all to Startup Academy. This academy is exclusively for ISS only. In the previous lecture, we completed all of the syllabus of our demand analysis, which also completes our statistics paper 3. And in today's lecture, we'll do one of the PYQ, which has been asked in the year 2018 from demand analysis only. So, the PYQ that has been asked is given like, first of all, we have to define Gini coefficient. Now, and then a data has been provided to us where we have been provided with urban and rural income of a grouped data, and from that we have to find out the Gini coefficient, and we have to find the Lorentz curve. But before that, what is the Gini coefficient? We did something related to this ratio in our relatability ratio in our that Lorentz curve equation, or in that we found out one relatability ratio. That relatability ratio is nothing else but Gini coefficient, which measures the amount of stability or the amount of equality in the income of a particular group of people. So Gini coefficient is the numerical measure of income inequality based on Lorentz curve. It is a numerical measure for estimating income inequality by Lorentz curve. With the help of Lorentz curve, we found out Gini coefficient. And the formula for Gini coefficient is G is equals to 1 minus 2 into area of Lorentz curve. This will give us Gini coefficient. Now, if Gini coefficient is equals to 0 and Gini coefficient is equals to 1, if Gini coefficient is equals to 0, then that is the case of perfect equality. That means income which is distributed in a group of people, or in a society which we are studying on, has equal in, each person receives equal income. So there is no inequality. So it has perfect equality. If Gini coefficient is 1, that means it has perfect inequality. Means every person is getting unequal income, and the society has unequal not perfect inequality. And therefore we can say that Gini coefficient lies between 0 and 1, since it is a probability only of Lorentz curve. So that's the case. Now, the data which has been given to us, before that, first of all, okay, let us first of all draw the data. Here we are taking rural data, where class interval is given and rural income is given. And in the on the next page we'll take urban data, because we have to calculate different Gini coefficient for different data, so that is why. Okay, so here we are taking rural data. So the rural data has the class interval has been given as from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, and 90 to 100. These are the class interval. And the rural share of income is rural income. I'm writing I. So it is given as 3, 4.4, 5.4, 6.4, 7.4, 8.3, 9.6, 10.9, 13.8, and so on till 30.8. This is the question that we have been asked. But before that, let us see what is the measure of the area. If we have to measure the area of a Lorentz curve, area of a Lorentz curve for a group data, then the formula is summation of yi minus y into xi minus x upon 2. Yi plus yi minus 1, it is summation of yi minus 1 plus yi upon 2, which is average of yi, into xi plus 1 minus xi. Okay, where x and y, x is the number of, x is the cumulative population of the share, and y is the income of that population. So here let us take first of all cumulative population. Cumulative population is taken to be as cumulative income of rural. This will be 3. Cumulative will be adding all digits as we go down. 12.8, 7, 8, 19.2, 26.6, and so on. You can write the cumulative. The last one would be 100. Okay. Now here in the question they have also given that each distribution of personal income has been taken by decile group. Decile means we have to divide them by 10. So let us take i's. I goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. These are the data that we have been provided with, and the xi here would be dividing I by 10, divided by I divided by 10. So this would be 0, 0 0.1, 0 0.2, 0 0.3 up till 0, up till 1. 1.0, 0.9, right? Like this. And here the yi column would be dividing this yi column by 100, dividing income by 100. So there will be one more column which is yi dividing cumulative income divided by 100. So first 0, there is nothing for 0, we will take 0. And for second it will be 0.03. For third it will be 0.074. For fourth it will be 0.128, 0.192, and so on up till If I divide it by 100, it will be 1. Now we know that formula for calculating our Gini coefficient or area of the Lorentz curve will be summation yi minus 1 plus yi upon 2. So yi minus 1 upon yi upon 2. If I take for this, it will be 0 only. This is area of Lorentz curve. This will be 0 only because the previous one is also absent. And this will be 0.03 plus 0 upon 2 into, now here we see that summation xi plus 1 minus summation xi. If we see xi plus 1 minus summation xi will be 0.1, xi plus 2 minus summation xi plus 1 will be 0.1. So it is constant, 0.1. The difference between them is constant. So we will directly multiply it by 0.1. Every of the term we'll multiply it by 0.1 and we will get our first answer as 0.00515. Like this, and so on. You can calculate for all the terms. Second one be 0.0052 and so on. We'll get if we get the total of this would be 0.358. This will be our total answer. This will be the area for our rural curve. And for that, we can calculate our Gini coefficient. Gini coefficient for rural curve will be, I'm writing GR, it will be 1 minus 2 into area of Lorentz curve, which is 0.358, 0.358, which comes out to be 1 minus 0.716, which is equal to 0.284. This will be the Gini coefficient for rural area, rural income. Now the second one that has been provided to us is for urban. Here it has been given for urban population. So here class interval 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, and 90 to 100. And here the urban income has been given, which is given as 2.3, 3.3, 4.1, 4.8, 5.8, 7.0, 8.7, 10, 14, and the last one is 40. Okay, now first of all we have to find here the cumulative income. So cumulative income would be, first it will be 2.3 only, for second it will be 5.6, for third it will be 9.7, for fourth it will be 14.5, and so on. And the last cumulative income here also is 100. Okay, you can calculate that on your own. Now again we'll divide them, and we have I here, xi here and yi here. And again, we forgot to draw one more column. Okay. So xi, yi, and area of Lorentz curve for urban population. So again, we can start from 0 or 1 because here there is no space for writing 0. In exams, you have to start from 0. So here we'll take 1, 2, 3, 4 and up till 10. And divide xi is dividing I by 10. We will be getting 0 0.1, 0 0.2, 0 0.3 up till 1.0, right? And yi is here dividing our cumulative income by 100. If we divide them by 100, it will be 0 0.023, 0 0.056, 0 0.097 and up till so on 1. Okay, now area will be summation of, we know that formula, summation of yi minus 1 plus yi upon 2, yi minus 1 plus yi upon 2, here will be 0.023 plus 0.056 upon 2 into xi plus 1 minus xi bar. So if I subtract 0.1 from 0.2, we'll get 0.1. Here also we'll get 0.1, and similarly we'll be getting 0.1 as a constant. So we'll directly multiply it by 0.1 and we get the first area as 0.00115. This will be our first area, and similarly you will get all the other areas by calculating. The total would be 0.302. So the Gini coefficient for urban is 1 minus 2 into 0.302, which is 1 minus 0.604, which is 3, 9 and 6.396, which is our area for this. Now Gini coefficient for rural was 0.284. So clearly we can see that Gini coefficient for urban is greater than Gini coefficient for rural, which means that the inequality in the inequality in income in the urban region is greater than that in rural region. Now if we have to draw the Lorentz curve, if I have to draw the Lorentz curve here, if I am drawing Lorentz curve, first is here and the second one is here. I'll draw first in detail and the second one you can draw. So here cumulative proportion of income we'll take. Cumulative income. So this will start from 0, 1, 0, 0.2, 0.4, 0.6 up till 1.0, 0.8. This will be our income, and here will be cumulative proportion of households, which are xis. Here we'll take yi and here we'll take xi. So our graph, equal graph should be like this. As we did in Lorentz curve, the equal graph should be like this. But as we draw it, it comes out to be like this, something like this. So this is the graph for Lorentz curve for rural sector. If you draw the points xi's and yi's from from your chart table, then you will get a Lorentz curve like this. And similarly, if we draw yi and xi from urban sector in this one, then we know that it will be straight line when it has to show equality, but it will deflect. A lot of it will be deflecting. Let us make this a little more. So we see that the deflection here is less than the deflection in urban sector. The more it get deflected from the equality curve, the more it will be greater inequality. So this is the urban sector graph and this is the rural sector graph, and from the graph as well we can see that the urban sector has more inequality in the income as compared to the rural sector. So this was your question and it was asked for 15 marks in your examination. All the things included, including the curves as well, Lorentz curve as well. It has been, you can see the question in your PYQ, exact question. The answer I have told you. I hope that it is clear with all of you, and if not, then you can ask in the comment section or on our WhatsApp channel. All your relevant doubts will be solved by us. All the best and keep on working hard. Thank you.